Imagine soaring across the ocean at supersonic speeds, cutting travel time in half. It sounds like a dream, right? But for decades, that dream was silenced. Literally, the deafening sonic booms of the Concorde made it impossible to fly over cities, leading to its retirement. Now NASA and Lockheed Martin are on a mission to bring supersonic travel back, but this time in near silence. In 1969, the Concorde took flight, becoming an icon of modern aviation. It was a marvel of engineering, flying passengers at twice the speed of sound. But the dream came with challenges: sonic booms, high fuel consumption, and expensive tickets. Eventually, regulations and costs grounded the Concorde for good in 2003. However, supersonic flight might be making a comeback with the X-59 QueSST, a cutting-edge aircraft designed to fly faster than sound without the disruptive noise. So how does this futuristic jet work, and could it change the way we travel? Supersonic flight began in 1947 when General Chuck Yeager broke the sound barrier in the Bell X-1. Decades later, the race for commercial supersonic travel saw the Soviet Tu-144 and the Concorde take to the skies. But while the Concorde operated successfully from 1976 to 2003, it struggled with high operational costs, noise pollution, and environmental restrictions. A 1973 FAA ban on supersonic flights over land sealed its fate. Yet the idea of faster-than-sound travel never faded. Scientists spent decades studying the sonic boom, a powerful shock wave caused when an aircraft exceeds Mach 1. The noise was so intense it could shake buildings and shatter windows. The key to solving this problem: changing the shape of the aircraft itself. NASA and Lockheed Martin's X-59 QueSST, quiet supersonic technology, is designed to reduce the impact of sonic booms. Instead of a thunderous crack, it will produce a soft thump, allowing it to fly over populated areas without disruption. The aircraft features an elongated, narrow fuselage and a sharp nose to prevent shock waves from merging into a loud boom. Built by Lockheed Martin's legendary Skunk Works division, the X-59 uses existing technology to keep costs down. It borrows components from aircraft like the F-16, U-2, and F-117. Its General Electric F-414 engine will propel it to Mach 1.5 at 55,000 feet, cruising nearly as fast as the Concorde but with far less noise and fuel consumption. One of its most futuristic features is the lack of a front-facing windshield. Instead, the pilot relies on an external vision system, XVS, a high-resolution camera setup that provides a real-time view of the flight path. NASA's goal isn't just to build a quiet, supersonic jet. It's to prove that the technology is not only feasible, but also practical for future commercial aviation. The X-59, developed under NASA's QueSST, Quiet Supersonic Technology Program, represents a significant leap forward in aviation engineering. Unlike previous supersonic jets, such as the Concorde, which generated disruptive sonic booms that restricted their operations over land, the X-59 is designed to drastically reduce the noise impact. If successful, this aircraft could revolutionize air travel, making supersonic flight accessible, efficient, and environmentally sustainable. The primary objective of the X-59 is to demonstrate how innovative aerodynamics and advanced noise reduction technologies can mitigate the problem of sonic booms. Traditionally, when an aircraft breaks the sound barrier, traveling faster than the speed of sound, Mach 1, it creates shock waves that merge into a loud, disruptive boom. This has been a major obstacle to commercial supersonic travel over populated areas, as regulations prohibit such flights due to noise pollution. However, the X-59 is engineered to reshape these shock waves, producing only a soft thump instead of a deafening boom. This capability is crucial because, if proven effective, it could lead to changes in aviation regulations, allowing supersonic travel over land. If the X-59 succeeds in its mission, the implications for air travel are profound. The future of aviation is taking shape, and the X-59 might just be the aircraft to bring back supersonic travel. With groundbreaking design and cutting-edge technology, NASA and Lockheed Martin are rewriting the rules of high-speed flight. Will we soon see passenger jets breaking the sound barrier once again? Only time will tell. But one thing's for sure, the era of silent supersonic travel is closer than ever. Would you board a supersonic jet if it meant cutting your flight time in half? Let us know in the comments below, and don't forget to like, subscribe, and hit the bell icon for more amazing tech and aviation content. Imagine traveling from New York to London in just over 3 hours, cutting transcontinental travel time in half. It's a dream that's closer to becoming a reality than ever before. But can we overcome the challenges of supersonic travel to make it practical, affordable, and safe? Let's dive into the cutting-edge technology shaping the future of aviation. For decades, the idea of ultra-fast aircraft capable of crossing continents in mere hours has captured the imagination of engineers and travelers alike. While aviation giants like Boeing and Lockheed Martin are advancing hypersonic missile technology, a groundbreaking company named Boom Supersonic is tackling a different challenge, bringing back supersonic passenger flights. With their XB-1 demonstrator and ambitious Overture airliner in development, the dream of supersonic travel might soon become a reality. But is this vision practical, and are we truly ready for such rapid advancements? Let's find out. The concept of hypersonic and supersonic flight has a long and turbulent history. Aerospace historian Richard P. Hallion once compared faith in hypersonics to belief in the second coming. Everyone knows it's possible, but no one is sure when it will happen. For over 60 years, hypersonic technology has seen cycles of interest and stagnation. Early challenges with rocket engines, re-entry protection, and air-breathing engine designs deterred progress. The Cold War-era military focused on traditional fighters and bombers, sidelining hypersonics due to their steep technological barriers. Today, however, hypersonics and supersonics are resurging, fueled by advancements in materials, engine technology, and the geopolitical arms race. Hypersonic weapons are viewed as game changers by the Pentagon, while companies like Boom Supersonic are looking beyond military applications to revolutionize commercial air travel. Boom Supersonic's XB-1, affectionately nicknamed Baby Boom, is a scaled prototype paving the way for the Overture, a supersonic passenger jet designed to carry 65 to 80 passengers at Mach 1.7. That's twice the speed of today's fastest commercial airliners. The XB-1's innovative design includes advanced composite materials, titanium, and stainless steel capable of withstanding extreme temperatures. Its sleek, swept-wing structure minimizes drag and maximizes efficiency, while its 3 General Electric J85-15 engines provide the power needed to break the sound barrier. But the real game-changer lies in Overture's promise to solve the long-standing issue of sonic booms. By flying supersonic routes primarily over oceans and subsonic over land, Boom's team aims to eliminate disruptive noise pollution. The Overture also leverages sustainable aviation fuel, SAF, striving for net zero carbon emissions, a nod to the increasing demand for eco-friendly travel. Despite setbacks, including pandemic-related delays, Boom has made remarkable progress. In 2023, the XB-1 completed its ground testing in subsonic flights, demonstrating its stability and efficiency. The company now aims for its first supersonic test flights in 2024 and plans to have the Overture ready for commercial service by 2029. The path to revolutionizing air travel with supersonic speeds is not without its hurdles, and one of the most significant challenges is cost. The Overture, Boom Technologies' ambitious supersonic airliner, comes with an estimated price tag of $200 to $250 million per jet. This high production cost will inevitably influence ticket pricing, especially in the early stages of commercial operations. The parallels to the iconic Concorde, which charged passengers around $10,000 for a transatlantic ticket in the 1990s, roughly $20,000 when adjusted for inflation, are hard to ignore. These steep prices made the Concorde a luxury experience, accessible only to an elite few, and the fear is that Overture might face the same initial exclusivity. However, Boom Technology has a bold vision that extends far beyond catering to the wealthy. The company's ultimate goal is to make supersonic travel accessible to the masses. Blake Scholl, Boom's CEO, dreams of a future where traveling across the globe at supersonic speeds isn't a privilege reserved for the few, but a reality for many. The dream includes ticket prices dropping to as low as $100 for a 4-hour global journey, a proposition that sounds like science fiction today. Achieving this goal will require breakthroughs in not only technology, but also manufacturing efficiency, operational scalability, and partnerships with airlines willing to invest in a new era of air travel. The race for supersonic travel is heating up, And Boom Supersonic is at the forefront of this groundbreaking movement. With their innovative designs and ambitious goals, they might just redefine the way we travel. But will supersonic flights ever become as commonplace as modern subsonic airliners? Or will the challenges of cost, noise, and infrastructure keep this technology out of reach for most travelers? Let us know your thoughts in the comments below. If you enjoyed this journey into the future of aviation, don't forget to like this video, subscribe to the channel, and hit the notification bell for more insights into cutting-edge technology. Thanks for watching, and we'll see you in the next video.